Okay, hey, welcome everybody to Sky Tour live stream on this wonderful day. And the date and time is actually the 18th of June at just about midnight. And I'm just going to get date and time up for 1 second. It's not up there yet, but it will be in a moment. Fantastic. What a nice night out there. There's no moon. It looks beautiful. Our date and time should magically appear up there in just a second. All right. And if it doesn't, well, that's just the way it goes. I'll make it work. All right, here we go. Ta-da! There we are. So welcome, everybody. Welcome to SkyTour live stream. It is I, Marc Antonio, and of course, I am here as always with our wonderful friend, Daryl. Hello, Daryl. How are you?
Hello, Mark. I'm nominal, thank you. Hello, everybody. How are you?
I always like the word nominal. Nominal. We hear about that in the space program. What's nominal mean? It means that working according to plan. Everything is going according to plan. Which is kind of cool.
Yeah, for me, that goes back to Star Trek II, The Wrath of Khan, when Spock went into the radiation chamber, whatever it was, and
yeah,
all of a sudden the screens flashed nominal up on the bridge, and they put it into warp. And
yeah.
bleep, bleep, bleep.
That's right.
Nominal.
I am now and shall always be your friend.
There you go.
And then, of course, Leonard Nimoy proceeds to die and then gets reborn because they couldn't do the franchise without him. Very cool. Yes, this is Messier 101 once again, guys. This is the Supernova galaxy we have been studying. And I've got 21 shots of it so far. We're going to just zoom in a little bit more here just to catch it. This is one of several places we're going to look tonight. But here you go. This is a beautiful galaxy. Let me just process it a little bit. We still have the sunset out there, so we are getting some brightness in the screen. You can't see the red, but if I zoom out, you'll see that there's a tint of red around the galaxy. That's the sunset light that's infecting it. But it's testament to the fact that our telescope is working as well as it is, that we don't have the ability, well, that we do have the ability to see a galaxy at all. I want to say hello to Judy M, who was the first one here. Nice job, Judy M. Renee Cruz is here, and we have Michael Hedrick is with us. What's going on, brother? And we have Sam S is with us. Nice to see you, Sam. C&D boy. And Gladys, hello. Cindy Murphy, nice to see you. I had a good Father's Day. Thank you, Gladys, and thank you, Cindy. And we have a satellite that went zipping through here. It's probably a Starlink satellite. If we zoom out, you might see how long the trail is. Yeah, it might be a different satellite, because the Starlink satellites... Oh, I'm sorry, no, it is 25 seconds, duh. So yeah, we're just cranking away here, waiting for it to get dark. So I figured, why not start with Messier 101? This is our incredible supernova that we've been able to capture and see. It's been great. Love this object.
Oh, yeah. It's been going just about a month now.
Huh?
Yeah, I think the Japanese guy that discovered it was on May 19th, his time at least.
Mm-hmm. That's pretty cool.
Uh-huh.
So I hope you guys enjoy what we do. We are cranking along. I want to announce that we now have a SkyTourShop. It is now available on Etsy. If you go to Etsy and search for SkyTourShop, you will be brought to our shop. And right now we have over 92 products, but right now we only have about 6 to 8 of them up there because we're slowly trickling them up. I just got these today, courtesy of Robin Curtis. These are SkyTour coasters for drinks. They're just so cool. Every picture is just stunning, and it's not showing too well, but I'm gonna I'll show you a little better right here. It's neat because it allows us to get some funding, get some help here. Like for instance, okay, if we just show the background for a minute. Okay, here you see this is the STLS Sky Tour live stream. It's backwards because I have my camera is backwards right now. Then we have a Pleiades coaster. It says Pleiades. All right, I know my screen is reflecting, and you see the Sky Tour logo down here in the corner. All right. Then we have these actually come. These coasters come with one object for 4, and we just mix and match. So you can get this one, the Flame Nebula, the Flaming Star Nebula in Auriga. You can get Messier 33, and we are making dozens more. So you'll be able to get coasters, and they're cork backed as well, and they're very thick. So they're actually quite a nice set of coasters, and it's a shiny, hard material that won't absorb moisture. And these will be available on the Etsy store as well in the next few days to a week at the most. Because we're working on get rid of the background. So we're actually working to create a bunch of these products because, we are viewer supported, and hopefully you guys can head to our store, buy some cool things, and anyone that gives us a donation of $25 or more is going to get a free SkyTour livestream T-shirt. Otherwise, you can buy one for $25 as well, but we're gonna actually make that number different, and we're talking about it now. We'll figure out a way to make it an incentive. Yeah, okay. So we have a lot to do, a lot to learn, but we're having fun doing it. Let's crank this a little bit. That's better. I'll color correct, get rid of the background reds. You can see the supernova right here. Okay, it's looking pretty. It's right here. Let me just put a box around it. Right there. There's our supernova. That little, it's looking a little orange tonight. I'm not sure if that's the actual color or if it's actually the sensor color, but the rest of the galaxy seems to be in the proper color. So I'm wondering if it's turning a little more red as it cools. I'm not sure.
You think? Still looks white to me.
You see a red fringe around it right now. But I see a red fringe around some of the other stars that are red. And then around the white stars, there's no fringe. So that's kind of interesting.
Uh-huh.
So we'll see. I am leaving for Roswell on the 27th. I'll be doing a talk out there and a live audience SkyTour live stream. Again, we had a very successful one at Contact in the Desert the beginning of the month. And hopefully we'll have a very successful one in Roswell. So you'll have a live audience. And learning from the first one, we're going to try and improve it a little bit in the way we do things. But it's still going to be just as exciting. I'm going to have the proper monitors, so I will have my own monitors, so I'll be able to see what I'm looking at. And it'll be projected on a big screen. I won't even have to look at that because I'll have my monitors. I didn't have the benefit of a second monitor to look at what you were seeing in this view. So I had to look at just a broadcast view, which is a very, very tiny view, which is kind of terrible. And I just want to say hello to Dean Bastador, who's with us, and I think I saw somebody else here as well, didn't I? Oh yeah, Betelgeuse, how you doing? Betelgeuse, you're gonna go supernova here soon. Not so sure when, but when it does supernova, we'll know because it's gonna send out a burst of neutrinos first. Neutrinos, that enigmatic particle that can pass right through you, as they are right now, and the Earth, and they're actually going to herald a supernova happening in the Orion system around from the star Betelgeuse. Supernovae are just so cool, and because those stars are so big, I've mentioned this before. Daryl's heard this, and some of you have. Because red supergiants are so big, and that's a stage of evolution just prior to a supernova. The supernova occurs in the core of the star, and the core of the star is down in the center of the star. It's only the size of about a big planet, okay, in the core, and that's where all the fusion's going on. And when that fusion fails, the rest of the star's mass is now going to gravitationally collapse on that core. And as it does so, that core collapse will cause a rebound effect in the center of the star, and now that outflowing shock wave is striking the stuff that's infalling into the core. And at a certain point in that time, there's going to be a burst of neutrinos released, leaving out all the stellar physics here. And when those neutrinos get released, they leave the star, and perhaps only 1 in 1 billion neutrinos gets out. But because there's many trillions of them, these neutrinos will come out of the star in copious amounts. All right? So, those neutrinos leave the star long before that shock wave, which is moving out from the core, reaches the surface of the star. Long meaning hours. So, we'll see just a few hours before a real supernova occurs, we'll see a burst of neutrinos from some point in space. And if we
I have a question.
Okay, and if we can figure out where those neutrinos come from, then we can figure out which star might be going supernova, and we can get our telescopes on it. Yeah, go ahead.
Okay, relating to what you just said about if we can tell where the neutrinos are coming from,
Yeah.
the neutrino detectors that we have built underground here on Earth, do they really have much resolution to them? I mean, they can't really tell the direction that neutrinos are coming from, can they?
Well, it's a large spherical or cylindrical tank with sensors all over the place on it. And I don't know if the sensors all go off at once or if there's just a statistical chance that they might get hit. But depending on the neutrino timing, all right, because the neutrinos are moving at the speed of light, right? So when the neutrinos strike the tank, because it's a big tank, they can calculate the difference between hitting the left side of the tank as it enters and the right side. If they get such a strike, then they can calculate when two detectors got struck by, say, the same neutrino, and that'll give them a vector. Okay,
Right.
It's not very accurate, and the detectors are spaced some distance apart, so it's going to form a straight line, possibly. But if one detector goes off, I'm not sure that it guarantees that the other detector in that same line will also go off. So I don't know that answer, but that's a good one to look up, Daryl.
That's pretty much what I figured. Gladys says neutrino, question mark. You might want to enlighten her.
Yeah, a neutrino is a small particle that's released during stellar nucleosynthesis. And neutrinos are given off during regular nucleosynthesis. So in other words, while a star is making hydrogen into helium, it gives off neutrinos. Our star does the same thing. It's part of the energy, the byproduct. But a massive amount of neutrinos being given off is what happens before a supernova occurs. And that massive amount of supernova neutrinos is the thing we want to detect. So if we see a burst or an uptick in neutrino detections, it means that there's a supernova that's about to occur somewhere. We understand the standard amount of neutrinos we get. You're getting bombarded by neutrinos every second of every day. Okay,
Billions
all over the universe.
Every second.
That's right. All over the universe, they're happening. And that's because they're a normal result of stellar nuclear fusion, like we see happening in every star in this galaxy we're staring at. Okay, so those neutrinos, as high-energy particles, are so energetic that they actually go through the Earth unimpeded, okay? And it's very hard to detect them. So they can pass right through, they can pass right through the Earth without even being detected. And because we have neutrino detectors, we can catch a statistical sample of them to know how many are there. You know.
So Gladys says, so what do neutrinos do?
Neutrinos are high energy particles, and so what they do is they travel out in all directions. They're a byproduct from a nuclear fusion reaction. What's that mean? It means that when a star's hydrogen is made into helium in its core, one of the many times that reaction takes place, you actually get a neutrino released, and that happens at a certain point in those reactions when you have two hydrogens come together, okay, into helium. A byproduct is a neutrino at multiple steps in that nuclear fusion process, and so there's a certain amount of neutrinos that are always present in the universe because every star is giving them off. Every star. All right, so they're just particles. They don't do anything. And that's sort of a lie, because I'd have to. I would have to explain how supernovae occur, because it's really the neutrinos in the end which cause the star to obliterate itself, and that's kind of that goes into the shock wave and how a supernova actually occurs, and I think we'll save that for a SkyTour radio episode, which we couldn't do today because of Father's Day. And thank you to those that wish me a happy Father's Day. I have a baby telescope. Yay. No, I'm just kidding. My kids are all grown, thankfully. No more diapers. Yay. So I think it's kind of tricky I know it's kind of tricky to detect neutrinos, but I think that the best thing that neutrinos do is they herald the advent of a supernova when you see them as a burst. And that's what we get. And that's probably what we would have seen from this star right here. Okay? I want to talk about cosmic rays mentioned there about getting notices. As Daryl has pointed out, because we're doing multi-streaming now, we're going to YouTube, Facebook, Trovo, Twitch, and Rumble. And because we're streaming on all those platforms, we don't have the ability to make a stream ahead of time and say, hey, guess what? Go check out the stream. Because I've seen that before when we create one on YouTube. People just join in, and like an hour before the stream, they say, hey, how you doing? Hang on, I'll be back. We lose that opportunity when we're doing it this way. I think that because of the multi-platform streaming process, we lose that ability. So that's why I have that little video that plays at the beginning, which is 1 minute and 10 seconds long. It kind of, sends the notice out, and then you hear about it, and then people might say, "Oh, they're streaming," and gives you that time to come in. And then we don't do anything for about 5 minutes into the stream, so that you don't miss anything. All right, so. Hello to Cosmic Ray. Hello to Ronald is here, ERRT Radio. Check out ERRT Radio on Mixler, guys. Ronald has a great radio station over there. Congratulations on that. And then Bullwinkle is with us. How you doing? JSCO is with us. Good to see you as well. So as we look here at our wonderful supernova, I'm really getting anxious to see this galaxy with our new telescope, which we will have. We have finalized an equipment list, and we will be getting a telescope. It's going to be an 11-inch Celestron. Okay, this is a 10-inch Meade that we're using. And as an 11-inch Celestron, I haven't decided on this part, and that is whether we're going to make it a wide field system that can see close up due to the more advanced camera that we might pick up, or if we're just going to leave it as an 11. Now, we have several options to do this, and we're going to try and figure it out. But we are settled on a telescope. It will be an 11-inch Celestron. And the mount, well, right now I'm looking at something called a harmonic mount. And the key there will be if it can carry the weight of the Celestron tube. And if so, we'll get a harmonic mount. That's not a name brand, that's a type. All right, so we'll see how that goes.
I was thinking the other night, last week when uh, that auction was going on, they had that 11-inch Rasa by
Yes.
Celestron. If you were to get that, I would think you could turn your present telescope or the SkyTour East telescope into your long focal length telescope.
That's correct, and that's one of the things I was thinking about. Uh, and we tried to bid in an auction on a this 11-inch telescope, uh, which Daryl is an RASA. That's the abbreviation, and it's an 11-inch. It runs at f2.5, so it's very fast, and so it would have a wider field, kind of like this one. But it would also allow us to take the existing telescope and go back to the f8 configuration, where, again, if f2 is fast, f8 is a little slower. But we could use the reducer in there to go back to, I think it's f6, f6.3. That
It'd probably be less on an F8. The F6.3 corrector is usually for an F10 system.
okay? Well, I know there's a lower F number that's available, and so that would give us the opportunity to really capture some cool details. We could be basically seeing a field this big in the galaxy.
Yeah,
Maybe. So that's the coolest thing.
I
So we would.
know the 11-inch edge version of the Celestron is a native F10, but the corrector reducer on it is an F7. So that might give you a little more of a wider field.
Slightly.
And other correctors, I think, are out there that are non-Celestron or non-Meade, that who knows what they have out there.
Yeah. Well, we're using the best people on Earth to help us figure these things out, and that's the folks at Starizona with David and Dean Koenig. Dean owns Starizona, runs it anyway. David is a Meade specialist who's helped us tremendously. And so I think it pretty cool. And Curtis Horn is with us. Hey, Curtis. And he says Night Owl is 0.4x by Starizona. Yeah, we're working with Starizona to figure out the right combination. And Ronald says, who's the RRT radio, I will be excited to see the new scope in action. Yeah, me too. Me too. And if you haven't guessed, we haven't got a fully dark sky out there yet. We have just a few minutes until it's fully dark, so we'll be able to see our night sky without any sunset light here soon. We're still getting a little.
I ran across a video on YouTube a day or two ago of a guy who had just obtained an 11-inch Rasa scope F2, and he was having some tribulations getting the thing dialed in. It was like image tilt or something of the sort.
Interesting.
Always something.
I can't. I'm trying to think if I saw that video.
I probably should have sent it to you. If I can remember,
That's
I'll
right.
try to find it and send it
No
to you
worries.
later.
Okay. Cool. All right. So yeah. So there was also in that auction there was a 16-inch Meade, and I opted not to bid on the 16-inch Meade. Now, it went for $5,250 when normally it's an $18,000 scope. So you might say, "Are you crazy?" No, I'm not crazy. Because guess what? If it goes bad, you can't get parts for it. Because Meade went bankrupt and is a Chinese company now. So good luck getting parts. Alice Pooper ordered the Triangulum Galaxy mug. We've got a lot more coming too. Thank you, Alice. And for those that, again, I'll put up a notice too. We definitely could use your support. We've been trying very, very hard to keep all this coming to you. This is, you can't imagine the expense. Oh my gosh. We're into this now for, oh gosh. Geez. Should I dare say? We're into this for well over $15,000 to $20,000 now. Computers and so forth. I actually wrote a program here, so now I'm going to be able to basically have full access to the building. So right now I have to wait for the timer that's running power to the building to come on at a certain time. But there's times when I need to get into the building and check things out ahead of time, or make changes or update software. I don't want to do that while I'm going to be streaming or near the time. So I want to be able to turn on the power to the whole telescope building. And I wrote a program here to do that. And I got a little tiny computer. Second one, I have a little tiny computer that I use when I do the road show with SkyTourShop live stream. And I bought a second little tiny computer whose sole purpose is simply to turn on the entire power system to the telescope and the cameras and everything else. And so that's working. So I just have to get the rest of the components, and then we can install it the next time I head out there. It'll be 1, 2, 3, and then bam, we have full power. I even set it up so that the little tiny computer, if we lose power, if power goes out, say there's a battery failure, because it is a green observatory, we don't have any wires. Basically, it's no power from a public utility. It's all from the sun, solar. So if for some reason the battery goes out or a breaker gets popped for some reason, as soon as it comes back, the little tiny power computer comes on after only 20 seconds. It starts up after 20 seconds. Gladys says, Mark, you should build an underground tunnel from your home to the STLS telescope. Yeah, that'd be great, but guess what, Gladys? I'm in the northeast of the United States, and the telescope's in the western desert of Arizona. So this is all coming to you from Arizona. This here, me, is coming to you from Connecticut, right? And all the verbiage you see on the screen here, this stuff is coming from Connecticut. The screen in the background here, all this stuff in the background, that's all coming from Arizona. So that's, and Daryl just mentioned that. Yeah, you can get a train too. A bullet train. Yeah, even the bullet train would take us a few hours to get to Arizona from here. Hello there, Django. How you doing? Mr. Django's with us. Welcome to you as well. I'm glad to hear from Belgium. We've heard some people in Belgium before. It's nice to see you. All right, so I am just going to give us a few more minutes here with this, and then we're going to move on to a nebula that we know about that should be coming up just high enough to see. It's one we shot before, and we'll shoot it again. And it's called the Blue Horsehead. Cosmic Gray says, so there will be no East Coast STLS? Oh, no, that's not true. Actually, behind me is that telescope, and it's just waiting for the building to get rebuilt out here, which we're going to be doing. I've just redesigned the building, though, to be a little enclosure for the telescope alone, so the building will just open up like a clamshell. And it will be able to open and close. And all it will hold is the computer for the telescope, and it will be... it'll hold a monitor, the telescope itself, the pier, the mount, of course, and just some of the hardware that I'm making, the hardware to run all the electronics and so forth. So we will have 3 telescopes. And we're actively seeking a southern hemisphere location as well. Because why not? I mean, who's with me? You want to see the Magellanic Clouds? Raise your hands. Heck yeah. All right. Well, this is nice. I'm going to make note of this. Haven't seen Izabela yet. Does she? Maybe she might be sleeping.
Yeah.
By the way, this is Messier 101, a face-on galaxy, and we are seeing it with a supernova in it. And the supernova is right at my pointer right there. It's right there. I'll show it to you in just a second as well.
I wish I could find. Back soon after the supernova happened, I was looking for light curves, and I found a couple of sites that covered it.
Yeah.
And I can't find the second site again. It had by far the best. Had a chart showing the light curve and everything, and magnitude and color.
Okay.
I guess that's in particular per what you said. That's what I'd be interested in seeing now. If it's A, if it's dimming, and B, it is dimming. We know that. But,
yeah.
B, if it's reddening as it's dimming now.
Yeah. That'd be pretty cool. I'd like to know that myself.
Yeah. But I don't see that now. I'm looking for it as we speak.
Well, I'm sure there's some options out there for light curves.
Big.
Yeah.
Some other time, not right now. Oh well.
Mm-hmm. Okay. Well, let's.
Lewis, it's dimming.
Hey there, Lewis. How are you? Yeah, Lewis asked the question: is the supernova getting brighter or dimming? Cosmic Ray, I don't know what to tell you. Cosmic Ray says nobody got a notice and don't have YouTube up 24/7. I don't know that you have to have YouTube up. If you're subscribed and you hit the bell and click all notifications, then YouTube's going to send you a notification to your phone, and I get a notification in Windows, for instance, that a stream is occurring. So that's all. There's a way around it. Hello, Bonnie. Bonnie's with us. Anahata.
I know. Hi,
77.
Bonnie.
I saw you said hi. That's why I said hi to her. I said, hey, Bonnie's here. Hey.
Oh. Well,
Very
Bonnie's
nice.
so nice, I say it twice.
I think you should. She deserves it 3 times. Hi, Bonnie.
Hi, Bonnie.
I did a talk out in I think it was I in Centennial? Was it Centennial, Colorado? And Bonnie drove like 4 or 5 hours to come listen to me talk. I was so humbled by that. What a great human being she is.
I'm surprised it's not more than 5. She's down in Pagosa Springs, way down in southwest Colorado.
Mm.
And nearly to Durango and the west side of Wolf Creek Pass and God's country down there.
Mm-hmm.
But it's a long drive.
It is. Well, let's take that off. We need to, we can move on here. All right. So, away. All right. And now, I would like to spend a moment to say to you all, please join our Patreon, which is right here. Our Patreon is here at SkyTourLive.org. In the upper right corner, you can see join our Patreon. And as a subscriber, you get some tremendous benefits. Now that our store is active, depending on your level, we'll actually be sending you some SkyTour swag, which you'd really enjoy. And we do have the store is on Etsy. I will put it up on the website, but it's called SkyTourShop. I will be happy to let you know more about that as I do, because I think that's it's a great way for us to get some assistance. And here is our Patreon list so far. We have John P, Izabela M, Ollie B, Chief McCyber, Vera C, Ronald T, Martin W, Raymond B, Cindy M, Terry H, Susan W, and Diane H. And I'll use their last names if they want me to. But that's all we got right now. We need many more. We need a lot more patrons, guys. You know, so we want to keep bringing this to you. And when we open up the second observatory, well, we're going to have a whole nother Starlink to pay for that location as well. That's our deal with the owners of the land, is that we provide them with their internet. And so we give them Starlink, and they give us a spot to put an observatory. Can't beat it. It's like getting $110 a month for free. And when you have plenty of room to spare, then that all works out very well.
I think they'd be happy enough to let you park another scope there at the present location.
We're working on that. We're thinking about it, but that's probably not going to happen, and it's okay. You know, it's protected land. It's hard to get to, and the location we're going to go to is not so difficult. We're not going to move this scope, though. This is going to stay here. All right, let's just... yeah, that's beautiful. All right, so when you see me save, okay, you'll see across the top, right there. There it is. We're saving it the file in FITS format initially, and then we're saving it exactly as seen. So FITS is an astronomical file format. There's free viewers. FITS View is one of them, FITS. And then we save this this ping file, and the ping file looks like the ping file is going to be a graphic file. And so when we save that file, right, then you see this. This is what you get in the ping file. Okay? So you'll see the galaxy, and you could then zoom in on the galaxy, and you'll see it just like we see it here. All right? And so that's what you see. And so this is available to you for free up on our server located at skytourlive.org. You scroll down a little bit and you just visit the site. You scroll down and it'll say, hey, take me to really cool pictures. And it'll take you right to our beautiful location where our server is. And you can enjoy it. Okay. So I just saved that there. So we're going to come out of this. And then I have another mode that I go into that I call night vision mode. Right, and that's basically what you'll see right now. I know, it looks like night, doesn't it? No, it says it's our green low light mode. Okay, and hopefully we will be able to find the next object here, which is pretty easy. So here is the telescope control. This is the telescope computer, which I can click on by tweaking it. All right, and then we have the telescope in the building, as seen in the building. And this right here is another view of the same telescope down low, looking up. There's the open roof right here, looking through the opening. Okay, this is the main live view. This is a 1 second exposure, just back to back and just going on live. This is our camera control cluster. This is our focus control. I already did focusing tonight to answer questions if you had them. So that said, let's go to the next object, which I would like to check out. So we're looking way up here right now, okay? And we're going to come down Yeah, we're up near Mizar in the Big Dipper. Well, while we're here, you know what? Why don't we check out Mizar? I think that's pretty cool. All right, Mizar's neat. It's a beautiful double star. We won't do any exposures of it, but we'll just go over to it so you can see what this beautiful star looks like. This is Mizar and Alcor coming up. Let's go down to 33%. There they are, down here. Okay, so these are these amazing stars. These are in the handle of the Big Dipper, and Mizar and Alcor are double stars. They're each double stars as well, if I recall. I know Mizar has another component that we don't see, and I think Alcor does as well. Am I correct on that one? I can't remember every double star that's out there. I was asking you, Daryl.
I'm sorry, I was reading chat. Say that again.
We have Mizar and Alcor here. This is Mizar and this is Alcor. And I think these are each double stars themselves.
Oh, I think you're right.
Okay. I'm gonna just do let's do a quick 10-second shot just to show you. Mizar is very bright, okay? And we'll come out of this and go into a stack and just get a quick shot of him after we clear our galaxy. This is our buffer.
Mizar is a 4-star binary system.
Okay.
Mizar itself, that is.
Yeah.
2 pairs of double stars, gravitationally bound. Still scanning here. Bear with me.
Sure. The halos are from the brightness, but we have special tricks to get rid of halos and processing.
Yes, Alcor is a binary.
Okay. Hey there, RJPX. How are you? Yeah, so this is Mizar and Alcor. Very hot stars. And you can see them. They're the middle star and the handle. And if you look at them with your eye, you should be able to split them like this. See Mizar here and Alcor. You should be able to see them with no problem.
Ronald asked how close they are, I believe, and they're about 0.36 parsec. Call it a light year.
Mm-hmm.
A parsec is 3.26 light years, so
Yes.
0.36 times 3.26, round it off, call it a light year.
You're answering Ronald's question?
I guess, yes.
Yep. Okay. Well, very cool. And, you know, because it's an official target that we looked at, I will save it. And I'll wait for one more exposure. And then we will move on. So, okay, so I will save this now. And save it exactly as seen once again. Alright, now we can come back and do our night vision mode again.
Daisy and Zoe are here.
Daisy and Zoe. Amethyst, how are you guys? You know, I used to go rock hounding for amethyst, and I would head out and I would literally belay down cliffs and pull out amethyst from veins in the side of these basalt cliffs. and it was scary at times. Sometimes when you slipped a little bit and the rope slipped to the mount slipped. But man alive, it was something else. And we got some beautiful amethyst here that I got in the cliff faces. It's not too far from here.
There is
Okay.
a mountain here in Colorado, Mount Antero, if I remember correctly. It's in the Collegiate Range or the Sawatch Larger Range.
Okay.
I believe it has amethyst on it. You can go out and pick the stuff.
Mm.
Also has garnet, if I remember correctly.
Yeah, I used to teach geology to uh, these special groups of kids that would come up to the science center that I worked at, and I would take them in school vans. We just got all these caravan of vans, and we would go out to a garnet schist site, and I'd let them all collect garnets, and they had a lot of fun with that. Here's what's coming up, guys. This is the Milky Way in our planetarium program. It's coming up. And
There's
right
the
now,
teapot.
yeah, in Sagittarius right here. And where we are right now, where we can see is up here. So we can see this area right here. Now, the other night we imaged Roofuki right here. And it came out stunning. You know, it was really stunning. But now we're going to do the blue Horsehead. So let's go there. And just for Cosmic Ray, as soon as Cygnus is up high enough, we're going to start imaging the Veil Nebula. There's, you know, it's like more cowbell, more Cygnus. Okay. There we go. That's the star. That's the double star there that we're going to put down here. And that will show us where the blue Horsehead is. Alright, so while that is aligning and capturing data, let's come up here and check it out. So the star is Java, and that is the double star that you're seeing in the image over here that we just saw. So we're going to pull Java down to the lower right of our view. Alright, and that's going to give us a better look. But first of all, I'm going to center Java. Right, because we're at 43% right now. Let me back out to the fullest view. And now what we'll do is we'll bring the telescope south a little bit. Okay, and then we'll head west a little bit.
Lewis, you may be thinking of the Horsehead Nebula.
I'll read his
is,
question too.
I'm sorry?
Read his question too so people know.
It wasn't a question. He just says that's everyone's favorite nebula. Made me think he's thinking of the Horsehead.
I think you're right, Daryl.
Which is Barnard 33 in the constellation Orion.
Yep.
Just under the star Alnitak.
Yep. Well, very close.
This is the blue Horsehead.
Yes, it is. Okay, well, our telescope, let me just do this here. I'm going to change the coordinate system. There we go. So, all right, we're all set there.
It even looks kind of like Jabba the Hutt.
Yeah.
Like
Han
a snowman.
Solo, Bantha Poodoo. Yeah. Well, that's because of a little bit of the overexposure. So, all right. So now we're gonna do this. We're gonna, now that we've centered on that star and synced our coordinates to it, I'm gonna drop Java down here and move east a little bit, because you see this right here? This is a red star cloud. I'm sorry, a hydrogen gas cloud. And so if we go east, okay, the blue is in here. So we'll see lots of blue in here. But this is just so cool. And what I was thinking is that we might take a mosaic of this by going down and to the left and up and to the right, maybe. I'm not sure. We'll see. So we can start almost anywhere, actually. So we'll start here, and you'll notice here it says searching. Okay. So right there, it says searching, and it's getting a star to guide on. And there we go. See, all these zeros. It's a zero calibration. Now it starts to guide. And so we have a blue cloud right in here and a red cloud right up here, and it really will be stunning. So let me get out of the way, and let's start an exposure. Now, I want to show you once more, if just for those that may not remember, the most important fields are the exposure here, and then the gain here. Okay. The exposure, of course, how long we're letting light fall on the sensor. The gain is how sensitive that sensor will be for that exposure. And the bigger the number, the more sensitive. So right now we're at 250, and 250 is not the highest we've used, but we can actually bump that up to 300. You'll notice it'll get a little more grainy here. There it is. But that's because when we bump up sensitivity, we get a little bit more noise, and we can get rid of the noise moving into this, but and we'll do a little bit of that. So we're going to do a 45-second shot here. We are guiding perfectly and with stability. So now I'm going to go there, and you'll know that we're guiding because you see right down here, right here. You see that? That right there, that little yellow bar, that little bar down there. That's our progress bar that tells you how much we're doing. Let's go over the wee and come back over here. Okay, so let's do our live stack now. All right, we're about 25 seconds in, and we'll start our live stack. This is our Alnatak. I'm sorry, not Alnatak. This is our Mizar and Alcor shot. We don't need that anymore because it's already saved, so we'll clear it. And we're 5 seconds from seeing our image. So here we come, and boom. You say, wait, what's that? Well, that's a unprocessed shot. Let's process it a little bit. Okay, and let's add a little color correction. And now you can see right here, you see some blue and you see some red. Okay, it looks like we also had a little noise. I was keeping my eye on the wind out there, so we're gonna clear this and try and start with and maintain a good shot. If it doesn't support a 45-second shot, it's only because of the wind. Because we've shot for 2 and 3 minutes. That's a better shot. Now you notice how noisy it is? You see how grainy it looks? Well, that graininess, right, that you see is due to that 300 sensitivity. If I brought this down to 100, this would be a lot less grainy, but I'll leave it here for now so you can watch what happens when the second image comes in, because if you look right there, you'll see that it says that we've stacked only one image. Well, we're about to stack a second image in about 10 seconds, and watch how a lot of this colored blotchy noise goes away, because the stars stay there, but the noise is random. So watch now. Here we go. Look at that. Suddenly, you see more definition in this cloud. It's subtle, but when they add up, they get rid of that noise. And as we back out, you'll see that the clouds are much more pronounced now and clear. Look at this beautiful red cloud, and look at this beautiful blue cloud. This very sharply delineated area over here is of particular interest to me. And we have more of the red up there, so we got a lot.
Windy says it's presently 12 knot winds south of Wickenburg.
Yeah, we got a lot of wind out there, but we're gonna try and salvage exposure.
Yeah.
Yep. Okay, so we know what this is.
Gladys, if you see the bright star in the lower right, Jabba, as Mark mentioned earlier, I believe that makes the eye of the blue horsehead. His nose is farther up toward the right, and then it's trailing off to the lower left.
Yeah, it's the horse is much bigger than the image we have here, and we actually have almost the whole image in here. Actually, see the whole image. I can just zoom out just a little bit more. Okay, so now you see the whole image, and this is 4 full moons across, which is 2 degrees, and 3 full moons tall, which is just over 1.5 degrees. So it's pretty big.
Can you go back to Stellarium for a moment? I think it showed it well.
Okay.
If you see that, Gladys, imagine the horse, the Jabba is the horse's eye, and that's his ear down to the lower left, and his head is narrowing as it moves up toward his nose at the upper right. That's the horse head. The blue horse head.
That's right. All right. So as you can see, we're getting our colors now. They're coming in very nicely. And we've only stacked 6 images. When I say stack, most of you know what this means now, but I'll tell you. You take an image, take a second image, align it with the first, so the stars all line up with each other. And you make an image sandwich over and over and over and over like that. And when you do that, you end up actually getting all the subtle data that's repeated, exposure after exposure, whether it's this really fine nebulous detail or this beautiful bright nebula or the starlight itself rises to the top, and the noise that might hide it is removed little by little because that's random noise. So you remove random noise and it's gone. And that's what we do here. That's what we've been doing. So let's just see if we can process a little bit. Oh yeah, look at that. See the rich colors in here? This is neat. And I'm gonna tweak a setting here to show you what's really out there. Okay, so I tweaked this setting. You'll see there's even more out here than we realize. See how much more? Okay, and we can, if we leave that up, we can actually kind of show that, and then get rid of some of that noise a little bit. See that? But we're going to come back because this is really, without pushing the data too far to where it's really, really noisy, we can actually just show you the imagery as we collect it of this entire region that's a lot more subtle. All right, now I'm going to pull this over. Look at that. That's beautiful right there. Hey, Jessica, how are you? Thank you for joining us. It's nice to see you. Yeah, this is the Blue Horsehead Nebula.
I assume the blue is reflection nebulosity.
It is. Yep.
Scattering, in other words.
Mm-hmm.
Rayleigh scattering.
Indeed it is. Yep. Okay, well, we know what the blue horsehead is, so we don't need to have its name in our view right now. So let's just let it develop. And what we could do, actually, this would be a fun one to try this on. Let's actually remove the telescope and slide this all over. And let's increase the size of our image on the screen so that people can see it a little bit more. And while I'm at it, let's take the stacking window out of the way for now and just give you a full screen of this. So as time goes on, we'll get rid of some of the problems that we see. The noise, still some of the noise is a problem here. Okay.
I know they're probably just random lines of stars, but as I sometimes do, I see a lot of star trains in that upper left of that picture. A lot of them are pointing more or less vertical.
I see this guy right here. See that one?
Izabela's here. Hello, Izabela.
Hi, Izabela. Izabela is a star SkyTour live stream person. You know, she does so much for us.
Well, she's just plain nice person too.
You know, they're hard to find, aren't they? Okay, we've stacked 12 of these images so far. You can see subtleties now in this red hydrogen ionized cloud, because you can start to see some more density here, and some lighter edges, the mixing with the blue reflection nebula. There's dust all throughout this image, you know, fine interstellar dust, several microns in size, basically. And that dust is what's basically reflecting the starlight from Jabba. Okay, and so that blue light, okay, is very short wavelength, very high frequency light, and those little tiny dust grains love to just absorb that blue light and send it back out in all directions, and that is called scattering. And for lack of a more accurate term, astronomy has decided to say those are called reflection nebulae when they're blue like this. It's always been sort of sticking to my craw a little bit. It's not really reflecting, it's scattering.
Yes.
So, and if you want to see a reflection nebula, you can see one in the middle of the day just by going outside. If it's clear and you have a blue sky, you're seeing the same exact nebula, effectively. It's just happening because of the scattering of the sun's blue light by the air molecules in our atmosphere. And that's why when you scatter more of that blue light, when more of the blue light between you and the sun is scattered, the sun's color gets red, or redder, I should say. It's called reddening. And that reddening is at a maximum when we see the sun on the horizon during sunrise or sunset. All right, because most of the blue light is pulled out between there and here where you're looking. And that makes the sun redder. And when we look in these clouds, sometimes we'll see with the denser clouds, we'll see that many of the stars are tiny little red dots. And those tiny little red dots might not be red stars. They might be white stars that have been reddened. And so, and that's called interstellar reddening, which we see often. And we have to calculate its value when we look at stars within nebulae and try and figure it out. It is breakfast time for Izabela. That's right, Cosmic Ray. And walking of the dog, Sky. See, a true astronomical person has dogs that are named after scientists in astronomy or Earth science objects. And so I had a dog, two greyhound dogs. I named them Tycho and Kepler. And Izabela has a dog named Sky. So you see, astronomers, we love our dogs. All right, so let's bring the telescope back. All right, there we go. And let's bring back our stacking parameters so we can actually affect some changes. We'll dock it back up here. Now let's see if we can. There we go. Look at that. Ah, look how subtle and look how beautiful. This is better than last week when we did this. You can see a lot of intricacies in this blue nebula that really weren't there as well. But then again, as time goes on, the march of time, it's higher in the sky by the time we look at it. RGPX says Zeus and Apollo. Yes, I saw Magnum PI as well. Zeus and Apollo were the Dobermans that they had at the estate. Zeus and Apollo. And Cosmic Ray has Hoagie the Dachshund. Daisy and Zoe have a cat named Luna. See, I have another dog though too, and I broke tradition because I kind of let the kids help name them, and so I had a dog named Indy, I-N-D-I, and I currently have a dog named Dingo, D-I-N-G-O, because she's a dingo doggy. All right, we're going to stop at 20 here, and then we're going to move down and grab some more shots. So Izabela, yes, we're going to do this. So we're going to save this right now. I screwed up. I forgot to rename it. My mistake. I'll do it now. All right. And then I'm going to, yes, I want the... I'm going to say no and save it again. Right, I got to wait for the next exposure. Okay, so once I get a 21st exposure in 1 second here, literally, now I can save it. Okay, and then I will save it exactly as seen. So now we're going to have one exposure of this in the wrong one. It'll be in the Mizar and Alcor directory, but that'll be fine. Okay, so now we'll get out of this and we'll move it. And all this is leading up to the possibility that we'll be able to see some other nebulae as they reach higher in the sky. So this is Java, and we're going to drop down and to the left a little bit. All right. So we're going to put Java up here and in the upper right, okay? So here we go. And then what we can do is we can stitch them all together in a split second with some software that we use. I've given this software to Izabela as well. Daryl doesn't do this yet. He may. We may convert him to the dark side.
I'm an eyeballs kind of guy.
Yeah, well, that's okay.
I'm too cheap to invest a lot of money in digital astro cameras.
That's all right. Okay, so we're going to go to here. And then we'll do this again.
Lubo, the halo you saw around the star, that is an artifact of the optical system.
But we actually use a filter called a UHCS filter, which I also have a filter by, it's called a radian filter. That's currently not here. But on the next telescope, we're going to have a filter wheel, and we're going to be doing narrowband filter shots as well. So we'll be able to do hydrogen alpha, sulfur 2, and oxygen 3, which are the three main emissions that you see from these nebulae. Okay, and it'll also catch the blue reflection nebula like we're seeing here. Okay, so we're going to go up to a 45-second shot again. I actually already have the filter wheel, and I'm working on getting those filters as well. There we go. And so now we're underway. And thank you guys for coming out here and joining us tonight. It's very nice to see you. So we'll clear this. We already did that one. Now that star down here is up here, so we're going to see the rest of the nebula down below. Yes, as Daryl's pointing out, that halo is due to the nature of the corrector plate on the telescope. And Ronald's asking, ERT is saying, will there be a planetary filter too? I have a 5-position filter, Ronald. So, our 5-position wheel. So I will have the, ooh, that's really pretty. I will have the, oh, this is beautiful. Look at this. We got the special stuff here. I will have the, all of the means to do narrowband photography with those 3 filters we need. And then I'll have 2 spots left. And one of those spots could be a planetary filter of sorts. I think I might make it a neutral density filter, which could make it something that's a little bit more beneficial to us, I should say. But we'll see. This is pretty down here. Look at that.
I bought a Mars filter for the last apparition of Mars.
Yeah.
And that thing was pretty much unusable. It was a screaming bright pink filter. And I mean, it was like a disco fever trying to look at Mars through that thing.
I bet it was.
Dazzlingly bright.
You probably need to have a neutral density filter in there, actually.
Yeah. I tried that, and I couldn't stack filters. You know, sometimes they put threads on the sides of each filter so you can combine them.
Mm-hmm.
And this filter, I couldn't attach anything else to it.
Yeah. Lubo says, I finally tried my L Ultimate on something other than M101. He was suspecting that it was not allowing much H alpha or oxygen 3O3 signal through because of so little brightness to M101. And he pointed at the Crescent Nebula instead, and of course was blown away because the Crescent Nebula is emitting far brighter than M101 overall. And that's really beautiful. And the Crescent Nebula is actually a Wolf-Rayet star, in process. Going to be a supernova there eventually. That's fantastic. Well done, Lubo. L Ultimate on the Crescent Nebula blew your mind. Yeah. Well, wait until you see it here. Wait until you see it. It's really, really pretty. Okay, we're letting this go a little longer.
Ronald, to expand on what you asked about, traditional planetary filters are just filters of different colors, and what they do is they help bring out contrast from color to color.
Yeah.
Basically, like a red filter on Mars or an orange will turn blue or green things dark and make them stand out more. Some colors are good for like bringing out the cloud bands and features on Jupiter and Saturn.
I mean, there used to be, with every telescope that you'd get, they gave you a lunar filter and it was green.
Yeah.
Now the problem with those lunar filters, the green, is that when you looked at them through a telescope, looking at the moon, oh yes, the moon looked much better. But then your color perception in that eye was off because it's over processing green, and then when there's not a lot of green coming into the eye it takes time for the eye to correct. So if you looked at a white wall, it'll look like two different shades of white. Or red colors would be muted in the eye that looked at the green thing, and in the other eye you'd see the red perfectly fine. A green color would look bright green, and the other eye would be kind of a dull green. All the complementary colors to green are muted except for green itself. It was actually quite a pain. So that's why I started using neutral density filters, which are gray basically, and they don't give you that stupid color perception problem, which really could be a pain.
Oh, that Mars filter I bought, that thing was it was almost useless. I mean, it was just
It was a
screaming
gimmick.
screaming bright pink or magenta color, and
Yeah.
it dazzled the eye so bad that had a hard time really seeing much of anything through it.
Yeah. I believe it. I believe it. Hello, James Dugan. Nice to see you. Thanks for coming out from Australia. We got people here today from China, from Brazil, from Belgium, and from Australia. This is truly a worldwide organization, SkyTour Livestream is. And we are a nonprofit organization. You can go to skytourlive.org, check us out. We have a live store now. I have to put it up on skytourlive.org, but it's on Etsy at the moment. We have a few products up there right now. So if you go up there, we have a total of 92 products, by the way, that we've made so far. And if you go up there, we have only about 6 or 7 up there right now, maybe 8. So check them out. And on Etsy, it's called SkyTourShop. That's the name of the store. And I think that you might like what you get there. You know, it's got some cool stuff. Everything from, we have lamps that have lampshades that have our nebulae on them. We have sneakers with nebulae. We have bathing suits for men and women that have nebulae on them. It's so cool. You never get anything like this anywhere. And all that stuff will be up there soon. I don't know exactly when. It's a matter of how much time I can devote to getting this up there. But it's up on Etsy. And right there on the screen, you'll see it in a second. It's actually SkyTourShop. It's up on Etsy, SkyTourShop right there. Okay, so check it out, enjoy it, and if you want to get anything, I can tell you that what we put up on there is stuff we've actually, made and purchased ourselves, so we could make sure that it's good quality. So we've actually put a lot of money into just getting the products up, making sure that they are perfect. All right. So on Etsy, it's SkyTourShop. Look that up in the Etsy search, and you should find it. I think that you won't be disappointed. I have some mugs here. I have tumblers, which we're going to be putting up soon. They're just stunning, and it's a beautiful tumbler, 20-ounce tumbler that has this gorgeous wraparound shot of like the flaming star, the rosette, and they're really cool. Did I say it was cool? Yeah. Okay. Sorry. This image is coming along nice. I'm wondering where we are with the blue Horsehead. Are we starting to get into the starting to head down toward the Antares Nebula here? Or Fuchsi? I'm trying to remember. Let's go look. Okay. So we moved down here and we're catching this right here. All right. So we're coming to, okay, so this, we have one more bit I should have moved over a little more, huh? Yeah, we're getting into Ophiuchus soon. And but if we back out of this, then Ophiuchus is down here. And then we have Alniat and the Antares Nebula as well. But right now, we're up here.
Mark, could you excuse me a moment, please?
Sure thing. So you can see, this is our field of view, this red square. Okay, 2 degrees by 1.5. And so you see these stars here, those are those stars here. Okay, you see that little orange star there, that's that little star there. And if you wonder what that star is, well, it's Hipparchus 79788, that star right there. Okay, and this star is actually more than one. It's Hipparchus 800 880019. All right, and this little blue nebula you see here is IC 4601. All right, so we can get names for all of these things, so that's really cool. And basically, this is where we are. All right, so Jabba is up there in the upper right, like I said before. And of course, there it is. And then we have these stars down here. And the blue Horsehead ends right about here, so I'm missing just a tiny little piece of it. And we have 15 here so far. That looks pretty good. Let's save it here. And this will be in the same directory. Okay. And save exactly as seen. All right. Okay, now what I'll do is, since I saved it, we'll go back to our night vision mode. Okay. And in our night vision mode, what we're going to do is we're going to move these over here and just slightly up a little bit. So we'll head to the east a little bit. And by the way, as far as the products go, I do want to thank Robin Curtis, who has spent many, many hours working on getting these in place. So she's really something. Thank you, Robin, publicly. Okay. Okay, this should be good now. All right. We're guiding now. Let's do a 45-second exposure here. Now you may wonder why we're doing all these. Well, we're making a mosaic. We're going to actually create a actual mosaic of these images, and we can make these available too to our Patreon subscribers as well. Okay, so 45 seconds. We'll clear this, go into our live stack. Okay, and these are the stars, okay, that we're seeing here. And out of the live stack, see those 1, 2, and then the 3. All right, so we'll come back in. And we have the 1, 2, and the 3, so they're now moved over here. So we should see just the tail end of this here. Should be just fine.
Looks like they're both double stars.
It appears they are. Yeah. Okay. Let's let this come in a little bit. Oh, did I messed it up, didn't I? I was supposed to clear this first. Sorry, guys. Now we'll see the stars. There we go. And the rest of it is here. Oh, we got a little more up there. Bigger than I thought. All right, let me clear it and move over some more. All right, let's do this and this. Okay, and let's move over to the east a little more. That's better. Okay. And because I'm gun shy, I'm going to go a little bit more. Okay. Oh, Izabela, thank you for putting up the link. We only have a few products, but like I said, we have 92 products, and I'm going to have them up there. Imagine getting a blanket. We have like a blanket that covers a queen-sized bed, and it's a gigantic Christmas tree nebula so far. It's just stunning. You see massive numbers of stars. It's just really, really cool. Okay, this is good. All right, let's... All right, we're guiding fine here. Here we go. 45 seconds. I'm waiting for the guiding to stabilize. You notice how sometimes it says searching, then it comes back, and it says searching again. It had to catch it. All right, so we're good now. It says searching. I think the average will be good. So what we're going to do is we're going to come in here now, do this, and clear this. So the question I always pose to people, especially my wonderful friends in SkyTour, is what has drawn you to astronomy? What has drawn you to astronomy? What makes you really excited about looking up at the night sky and then seeing it through our eyes of our special scopes? That's a question for all of you. There we go. Look at that. Okay, and we'll color correct it. Yeah, see now we have the whole rest of that blue Horsehead.
Can I start?
Yes.
Uh, Lifelong interest, and I've told the story before about once I learned to read and got taken to the library and the kids library down in the basement of the Carnegie Library. There was no stopping me. I started checking out all sorts of science books. Uh, the first astronomical thing I remember seeing was, I think it was about 1965. I want to say it was Comet Ikeya-Seki.
Okay.
There were other things. I remember reading about the moons of Jupiter and how bright they were and just the way they're situated. And I went out and tried to use a telephone pole to occult Jupiter one night and still see the moons off to the side, naked eye, and I thought I could. I had sharp eyes back then.
Mm-hmm.
Uh, Stuff like that. Just always had an interest in it, and I finally got
That's
my
great.
first telescope, 1981, if I remember right, 42 years ago,
Nice.
and there was no stopping me after that. That's when I
Well,
lived up in Leadville, and I got spoiled by the skies up there.
yeah. Ronald has this. He says, I've always had an interest, but you're one of the few that have made it super easy to enjoy. Well, that's cool, Ronald. Thank you. James Dugan in Australia says, grew up with the Apollo missions, always had an interest in space. Yeah, me too. Me too. In fact, it was one of the scientists at NASA that got me into astronomy, as a matter of fact. Sam S. says, I'm amazed about how much I remember from my reading of Astronomy Magazine years ago. That's right, Astronomy Magazine was out there. I actually did a review in Astronomy Magazine years and years ago. Anthony DeSanto says, looking back in time has always amazed me. And that's right, Anthony. How many people remember me talking about, and Daryl, about how when we look at an image like this right here, we're looking back in time. At different times when the light has reached us from these stars, they're not all the same distance. If they were, it'd be all the same time. But it's not, right? So, seeing the sky like this and realizing you're looking back in time, it really can mess with your head if you start to realize that when you look at Orion, you're seeing as it was 1,500 years ago, 750 years ago, 2,000 years ago, because everything is at different distances from us, and it takes light that long to get here from there, right? So yeah, it's pretty cool. Izabela says the infinity of the universe, but my parents talked me down and forced me to become an artist. I wanted to be an astronomer as a teen. Yeah, I was told many times by my parents, Izabela, why don't you get a job doing something that'll make you lots of money? Yeah, I guess I could have been a doctor if I felt like applying myself. But I just didn't want to be a doctor. I had too much fun looking up at the sky and looking down into the deep ocean. So I knew I was going to go into one of those two sciences. And I ended up doing astronomy. You know? Now, had I not done that and did oceanography, then you know what I'd be doing right now? I'd be having a live shot from a drone underwater that I would be running and doing a public stream. Trouble is, I can only do it at times where I could actually have a clean signal to the ocean somewhere, and of course, anything you have on the ocean is far more prone to failure, so there would have been a lot more costly. So I'm glad I did this. Okay,
Somebody
RGBX says,
mentioned
what?
somebody mentioned the Apollo program, and I think you talked about NASA also.
Hmm?
I go all the way back to the beginnings. I can barely remember even before the first Mercury mission, and that really fired the imagination of both my twin brother and myself, and
Mm-hmm.
we were hooked on that from the very beginning. We drew rockets all the time, and you name it, and then we discovered science fiction, and we're both really hardcore into sci-fi.
Yep.
It's the whole 9 yards.
Yeah, and then let's see. RJPX says he's also a huge sci-fi guy, but he also says above, I think it's like Neil deGrasse Tyson put it: the universe chose some of us. Uh, Even if I'm not doing it professionally, I had my interest since childhood. Yeah, and that's usually what we see: people infected, infected with the astronomy bug. Um, and Cosmic Ray says in the 50s, the sky was glorious and aurora common. And to be able to make my own telescope, my own mirror, I did that as well. I made a 6-inch telescope mirror. Um, and we ended up selling the blank to somebody else because I didn't have the time to finish it. But that's cool. And Gladys says, I still want to be an astronaut, although that's not the same as an astronomer, lol. Yeah, it's true. There's not much use for an astronomer in outer space. But
Yeah.
yet, I was going to say, yet. And then Sam S says, I used to have a 45 RPM record of the sounds of rockets blasting off. That is very cool. I'll admit something to you guys now, and this is embarrassing. Remember when, in the original Star Trek series, when they started up the warp engines? And you heard them like the... I love that sound. I don't know why, but I actually bought a record album that was by Gene Roddenberry, and it was about Star Trek. And in it, there was this one 10-second clip of the warp engines running up. And that was my favorite part of the album. I played it over and over and over and over and over again. Did I say I played it over again? Yes, I did. Over and over. Crazy. But hey, that's what you do when you're a kid. I don't do it anymore, no. I don't. But just so you know, I don't do it anymore.
I used to use an astronomy vendor called Pocono Mountain Optics in Pennsylvania back in the 90s, and
I remember them.
They were my go-to, and I called them one afternoon to place an order, and they answered the phone, Pocono Mountain Optics, and I heard the red alert klaxon from Star Trek The Original Series going on in the background.
Yeah, somebody was watching it.
Yes. I asked, and they said, yeah, it's on the television. It was funny.
That's funny. Yeah. So this is coming out nice. So this is the back end of the horse's head down here somewhere. And it continues up to the right. So we'll be able to make a mosaic of these 3 different shots we've made. And Izabela, thank you. She's putting up the links to that for you. And hopefully, like I said, you guys get a chance to head on out to our Etsy shop on SkyTourShop. As I said, a lot of products that are still going to be going up there. We have some up there now that we vetted and come out really great. But there's more coming. More coming. And to those here, I'll just show you real quick again because I wanted to. We actually also, this will be going up, these will be going up, coasters. STLS coasters. They have a cork back on them. They're thick and they support your drinks. We have the observatory. We have the Pleiades. Okay. And we have the Flaming Star Nebula. All right. And when you buy a set, you get 4 coasters, and they're all the same object right now, but we're thinking about a way to give you a variety. And then we have Messier 33 as well. So we have Flaming Star, Messier 33, as I said, and then we have our wonderful Pleiades. Okay, trying to get that out of there. And these are all backwards right now because I have the camera reversed right now. But these are beautiful, and they come in a set of 4. And there's tons more objects up there. You usually see the desk lamps. The desk lamps, a beautiful pewter desk lamp that has a shade on it that is got one of our images on it that wraps around and throws the beautiful reddish blue light from the nebula. Oh, it's gorgeous. It's like living in the nebula. Your room is covered with that light. It's beautiful. Let me go back to hiding the background a bit. There we are. Very cool. Okay, we got 14 shots here. We'll stop at 15 here. And this will be the last in this series.
Can you zoom in on the pair of stars there mid-right?
I will. In just a second. I'm looking at, I think, what you're seeing. You're seeing some detail in the blue nebula there.
That too.
Okay. All right. So let's zoom in on that. Let's move it over. Yeah, look at that. So we have a pair of stars here. We have a star here, and this little star here, probably not related to this star. Might be a background or foreground object. I'm going to guess background, because I think it's deeper in the nebula and maybe has its light reddened, which is why it looks this way. Yeah, pretty cool.
That's nice.
Sam Esmet, Frank Borman, that's cool. I had dinner with Alan Bean. He came to the Science Center where I was teaching astronomy, and we were both space artists, and he showed his work, and I showed him mine. I brought my portfolio, and I showed him, and said, oh, look at this, Captain Bean. And it was actually him on the moon doing one of the experiments. And he says, that's cool. Now, I was a peon here, and the guy that ran the Science Center wanted to take Captain Bean out to dinner. And, of course, I was invited, but not as anybody special. I was just invited as a staff member to be nice. But Captain Bean said to the director, can Mark sit with me? and we ended up talking the night away, and the director sat there kind of like, not sure what to do. He kept a smile on his face, though. But that's what happens when you get people together that have the same like all of you. You know, good luck shutting them down. You know, that's a beautiful little nebula.
Mm-hmm.
Okay. I'm going to do, now that we've got 17, 18, I'll do one more save. And this one will have even more data that's the random noise data that's removed. Excellent. All right. So now, the only thing left to do here, I think, is to bring this up. All right. And it's smaller right now on purpose because, you know, I don't want to, I want to show all of it while we're doing the mosaics. I think the only thing left to do now is to go up. And head over to the west again. And let me just check in my stellarium. Okay, so we want to go over to Jabba and just catch this upper edge, which I don't think we caught before because we were kind of here. So I think we're going to actually go up here, put Jabba down just below center. So we're going to head over to the west now and get Jabba down below center. And then this should all be able to link up. So Jabba should be coming in here soon. There it is. Okay. All right, there we go. And then we'll go north. All right, one more jog. think that should be good. We're gonna do a quick shot of this. I'll get rid of this shot in just a couple seconds. I'm just gonna do a quick 45-second shot of it to see what we have there. And that's not what we want to see there yet. This is all the blue Horsehead, guys. It'll be back in a moment. Move that. All right, we got it. That's good. Okay, so we'll continue. Sort of reminds you of another nebula that we see in the winter, known as Witch's Head in Orion. So this is the top of the horse right there. It ends right there. Comes around. Pretty cool. If anyone has any questions, I am happy to answer them. Let's just wait for a few more of these to come in. So far, the wind has been very cooperative. Very cooperative. Okay, I'll work on a couple of things here for a minute. Gladys says she gets motion sickness. I get motion sickness too. But it's not going to stop me. Okay, Michael, I'll wait for it. It's not going to stop me from riding the Vomit Comet, which is that weightless airplane. I certainly can't afford to do it. I'd have to basically get a ride for nothing somehow. But you never know. Never know.
What's your question, Michael?
I think he's writing it.
Yeah.
These colors
Michael,
are going to start to come in nice.
Betelgeuse is behind the sun right now.
Actually, it's very close to the sun right now in terms of look angle.
Yeah, it's lost in the sunset or the sunrise, as the case may be.
Well, it's lost in the daytime period.
Yeah.
Hey, Casa Gray, I'd pay good money to see you on the Vomit Comet. Well, never say never, right? I'm sure there's a way. Where there's a will, there's a way.
Oh, this is why all those dumb videos on YouTube talking about some of them say Betelgeuse has gone supernova, and
Yeah, those are stupid
it's
videos.
silly because we can't see it right now.
Yeah, it's just people trying to get clicks.
Oh yeah, but some people believe that stuff.
I agree. Some people do, and I'm not
Michael's
some people.
question continues. He says, "I mean, would it be too bright to see with the telescope if it wasn't behind the sun right now? Too bright?
Um, if you're talking about when it goes supernova, it might be a little bit bright for cameras and a telescope to capture properly unless you use a short exposure and just show only Betelgeuse because it's going to be visible during the daytime. Um, so it'll be really bright at night if it could be seen at night. I'm reading kind of into your question, not sure if that's where you're going, but that's that's the truth there. He says cool, so maybe we answered him, Daryl. Not sure.
I forget. How far away is the Crab Nebula?
Oh, is it 3,000 or 5,000?
I want to say like 5 or 7. I forget, but
Okay.
that far away, and it was bright enough to see naked eye in the sky in the daytime.
Yes, it
Uh,
was.
Chinese astronomers saw it. I'm sure Betelgeuse would be dazzlingly bright. You could always point a telescope at it. If you've ever seen, probably the brightest thing I ever saw besides the sun was iridium flares. The old generation of iridium flares, they could get past magnitude -9, and they were downright painful to look at. And um, I mean, that's 5 magnitudes brighter than Venus, and Venus is -4.
Yeah.
Uh, and so that's 2.5 to the fifth power, I guess. Uh, I'm sure it'd be brighter than that. Might be unpleasant to look at, but hey,
Mm-hmm.
you don't see Betelgeuse supernova very often. Ha ha.
Only once. Now, Izabela, ever thoughtful, has a question. She writes, if the whole universe is expanding, does matter at the quantum level expand too? If yes, how does this affect the quantum fields? Do the fundamental forces become stronger to hold matter together? Okay, let's take it apart. If the whole universe is expanding, does matter at the quantum level expand too? Meaning, if I read you correctly, does the distance between protons in a complex atom, like say an oxygen atom, do they get farther apart from each other? The answer is no. And do the fundamental forces become stronger to hold matter together? The fundamental forces' strength doesn't change. We understand the magnitude of the strong force, the weak force, the electromagnetic force, and gravitational force. Those forces don't change, they increase in magnitude depending on mass. And where does mass come from? Oh boy. Mass is a quality of objects in the universe, quality of matter, that is given to it by a very special particle called the Higgs boson. And that's a whole nother mind blowing discussion to have at some point. We'll talk about the Higgs boson down the line a little bit. Known as the God particle for reasons that I just alluded to, because the Higgs boson and the Higgs field actually provide mass to the matter through the interaction. Really interesting how the Higgs field works. With that said, so to answer your questions, Izabela, directly, the whole universe is expanding, yes. Does matter at the quantum level expand too? No, not in the way that you may think. And if yes, but it's not, does this affect the quantum fields? The quantum fields may change, but for other reasons, not due to the expansion of the universe, because the fundamental properties of an atom stay the same no matter how fast the atom is expanding in the universe. We get closer to light speed, and then atoms act a little strange approaching light speed. And that said as well, the fundamental forces get stronger? No, they don't. They stay the same magnitude. Right. And Tim F is here. Hey, Tim. And Desert Dweller's with us. Hey, Desert, what's happening?
What we see of the universe effects of so-called dark energy and dark matter. Uh, those are like more cosmic scale things. I mean, dark matter. You could say, I guess, they see it on a galactic scale. Dark energy. I would posit that maybe it's more of a supercluster scale.
I would agree with that, and to put it in terms that you can grasp, I think a little more roundly. Dark energy is a repulsive force. It doesn't mean it's ugly. It means that it repels matter away in all directions. And this explains the accelerated expansion of the universe in a way that I would have to say is still not well understood. Now, I liken the expansion of the universe to a very simple metaphor. Take a balloon, blow it up a little bit so it's a little round ball, not fully expanded, and put dots with a Sharpie on it, all over it, all around it. And now you measure the distance between some of those dots and then start blowing up the balloon. You'll see that every dot on that balloon is moving away from every other dot. Okay? See, that's an analogy for the universe expansion. Okay? Now, as you blow up the balloon, force more air into it every second, and that's an analogy for the accelerated expansion of the universe. Okay? The dots are moving faster and faster away from each other all the time. And so what's the size of the universe's lungs? Can't tell you if there's that property in there. But it's pretty interesting how it all works. Hello, Marco. And I agree, Michael Hedrick. Izabela had an awesome question. Cosmic Ray says the trips on NASA's weightless wonder, the Vomit Comet, would cost more than $5,000 per person through the Zero Gravity Corporation. I think that price is updated. Unless you checked it just now, Ray, the last I checked, it was over $10,000 a person, and I think it starts at $10K and goes all the way to like $18K or $24K even to fly in this thing. So I'd have to be awarded a trip. I'd have to get it for free. And you do this, you fly these parabolas, you do about 15 of them. So if you get sick on the first one, you're doomed. For 14 more trips, you are doomed, because you're going to be sick as a dog for the entire trip and you won't be able to enjoy it. I'm probably going to be that guy. If I ever get a chance to go on this, I'll probably be that guy. But that's all right. Okay.
I'm not sure.
We're going to stop.
I read that I guess it's Virgin Space, whatever they call themselves,
Oh
is
yeah,
going to
the
be
balloon
start
trips.
selling commercial tickets for their suborbital flights soon.
Yeah. Well, so is Blue Origin,
Yeah.
right?
Blue Origin, that's an expensive amusement park ride, is all that is.
Yeah, it's sort of sort of an expensive amusement park ride, but it's not that bad. It's actually pretty cool. Uh, and if you've been on the drop tower, uh, at like a theme park where you have that that really tall tower, you go up to the top and then drop, right? Um, that's what happens when Blue Origin goes straight up and it starts to fall. It's while it's falling that weightlessness, your stomach doing those flips and everything. That's what astronauts feel all the time. You have to sleep in it, you have to work in it, go to the bathroom in it, take a shower in it, while you're in that confused state in your brain. Your brain feels like you're falling the whole time. I think it's pretty interesting. It's something I'd like to try someday. I want to feel like I'm falling all the time.
I
Um,
was wondering how much Virgin Galactic, Michael says, how much Virgin Galactic or Blue Origin, for that matter, charges for a ride when they have commercial customers.
oh well, I mean William Shatner rode the Blue Origin thermos bottle into space, crossed the Kármán line, and and so I don't know if he paid for it or if he was given it because it was Captain Kirk.
I thought I heard he was giving it.
Yeah, that's what I heard too. But they had corporate customers on there, and they paid maybe over $1 million a piece. I don't know. I mean, it could have been way more or somewhat less. I don't know. You know, something else. All right, we just finished this guy. All right, so I'm going to get out of here. Oh, it's 2 a.m. Holy cow. Um, so this is up on the server right now. I'm sure somebody will post the link. And let's go and go into our 1 second mode. This is our wonderful night vision mode. Let's go see if we can see one more object. All right. Yeah, I think this is we're almost straight up and down here, I think. We're almost looking due south right now. Let's just go this way. You just have to see a little higher up. Yeah, we did this last time. Yeah, there's a lot of globulars seen through the galactic plane here. This is the galactic plane you're looking at right here, the center of the galaxy in this direction. All right, let's go and let's go and do. I know what I'm gonna do. I'm trying to find it, see if it's up or up high enough.
What are you looking for?
I was trying to find the Sagittarius star cloud. It's there, but it's not. It's not high enough. Let's see about the Eagle Nebula. Its altitude is plus 35, and that's going to be not quite high enough. But the farther north we go, the better chance we have the Scutum star cloud.
Yep.
and that's up at almost 40. We might be able to do this. Let's check the wild duck cluster. Let's see if we can do the wild duck cluster. Let's see what we get.
Izabela, I read that some guy fell from the catwalk over the Grand Canyon the other day. Fell 4,000 feet. And no, he didn't make it.
Yeah, for sure.
There's like a glass catwalk built on the west side of the Grand Canyon outside the national park. It's actually on an Indian tribe's land.
Yavapai, yeah.
He must have climbed over the wall to have fallen. I don't know what the heck he was thinking. Heights used to not bother me. Now they do. I visited the north rim of the Black Canyon here in Colorado years and years ago. I'd been to the south rim many times. It was developed. It's a national park now. Back then, it was just a national monument. On the south rim of the canyon, there are walkways and handrails and campsites and all that happy stuff. But one day I drove around quite a drive to get to the north rim of the canyon. It was about a half a day drive. And it's out in the middle of nowhere on the north side. It wasn't developed at all, at least at the time. I don't know if it is now or not. Just country highways and then country roads and then a gravel road. And then you came to a little gravel parking lot. You get out in a very short walk and all of a sudden, boom, 2,600 feet straight down. And no handrails, nothing. Just all of a sudden, it just boom, 2,600 feet straight down. And I had to sit down on my butt and scoot back away from the edge. It freaked me out so bad. And I've kind of had a thing about heights ever since.
You need to skydive.
No, I don't.
You'll make that right out of your system.
Yeah, no thanks.
I don't know. I talk big. I won't jump out of a perfectly good airplane. I'm sorry.
Right.
Okay, this is the Messier 11, which is the wild duck cluster, and it's red because we're impacting the edge of the observatory a little bit, but you can see what's waiting for us. These are all stars. Absolutely incredible. Wow. So it's not quite high enough. It should be this yellowish color down here as well. It's part of the same star cloud. Ay, ay, ay. Well, that's too bad. All right, well, that's all right. You know what? It's coming up. It's coming up. And we'll see it. Okay, you know what I'm going to do? Because I never say die, I'm going to, I'm just going to go to this spot in the sky. All right. And we'll try that out and see what that shows us.
Marc, Izabela has assembled mosaic of the blue Horsehead did tonight.
Mm-hmm.
Give me just a second.
You know
I'll
how
move it over
she
to you.
does. You know what she does. She's something else. Okay. Thank you, Izabela.
Okay. Let me see if I can remember how to get it over to you.
Just drop it in the chat. Oh,
Yes.
I guess you gotta figure out how to do that, right? I see what you mean.
Here it comes.
It's tricky. Okay. Yeah,
Appears to be a
might
rather
be
large
needing more.
file. I'm sorry.
I was just talking to Izabela. She says, in my opinion, it needs more images. I think you're right. But we're starting on it, and nice thing is we can do a mosaic tomorrow or the next day. Okay, so let's just do. This is just a random 30-second shot in the Milky Way.
Okay, you have it.
I see it. Thanks. While it's doing this, I'm gonna set up our shot here. I won't be saving this one yet because we're hitting the rim of the building. Here we don't have the rim coming in. Okay. All right. Let's see here. Let's do this first. Let's see what we got here. I like these little discoveries. Look at this. Just a random picture shows some incredible details here. Wow. Neato. Okay. Hang on, guys. I'm just working on this. Here we go. Oops. Where'd it go? Oh, there we are. All right. Let's see here. Trying to get that to show bigger and I can't. Sorry about that. I'll work on it and show it to you. Might be because I'm tired or something. Look, it's just a random location in the Milky Way and we see these beautiful dark clouds in here. Astonishing and so cool. Alright, maybe like this. Let's see. Look at that. Okay, there is the mosaic we just did. It's a little fuzzy. You don't see it there, I know. I'm sorry, because I'm showing it on the broadcast screen.
Okay.
Alright. Yeah, so that's pretty good. That's pretty interesting. There's Jabba, and this is the other part down here. So we see the entire thing almost, and we could have had a few more shots up here. But we're working on it. That's pretty cool. Thank you, Izabela. All right. Let's...
Yeah, I had the full-size one, and it looks quite sharp, and I can zoom in on it and all that good stuff.
Yeah. The way I was showing it didn't allow me to do that, but that's okay. I have to bring it into my image viewer, which I was just bringing it into a window, so it's okay. All right. Well, this is the last image of the Milky Way for tonight, guys. And we'll be following up with this for sure, because this Milky Way is going to be around for several months now. I can't wait. So in any case, I want to thank you guys for coming out tonight and exploring the universe with us, the universe live in real time. Please do go to SkyTourShop and check it out on Etsy. We'll be adding more products up there. There'll be more up there tomorrow, more up there the day after. Now that we're getting things going. And we could use your support. And I hate to sound like a telethon, but we do need your support. Especially since we're opening another observatory. We are going to be spending a lot of money on the internet per month. So your support helps and counts. Thank you guys. Consider joining Patreon at SkyTourLive.org. Become a Patreon subscriber for as little as $5 a month. That'd be great. I hope to see you guys there. If it's worth something to you, why don't you show us? That'd be cool. Anyway, I would really like to let you know that I really appreciate you guys. I really enjoy this. I think it's clear that my passion is in the right place. All right, guys. You have a good night, and we will talk soon enough. So good night, everybody.
Good night, everybody.
What he said.